In this lesson, we'll address the question, why should we get knowledge? And one of the take-home messages will be, the more we know, the better thinkers we can become. Let's first tackle what we mean by thinking. What is thinking? Thinking occurs when you combine information in new ways. It might be a new math problem. We have to add 45 plus 28. We've got to do some thinking here. A new language problem, reading a new text, trying to understand what we're reading. A new logic problem, checking that someone's reasoning is valid, that their conclusion follows from the thinking that came before. Or a new argument problem, checking an idea against available evidence. Now, this thinking is thought to occur in a memory system called the working memory system, sometimes called working storage. And it's the workspace for integrating and manipulating information that can come from the environment or long-term memory. Here we see some of the features of working memory. It operates over a few seconds, so it's sometimes associated with short-term memory system. So it's a temporary storage of information that can come from long-term memory, but also just information from the world. We, of course, have access to our goals. Our current goal might be to do some thinking about information in our working memory system. It's in the working memory system where we're going to manipulate information, for example, adding those numbers to get the addition. And working memory is closely associated with attention systems, because for this thinking to succeed, we've got to maintain the information in the working memory system and block other irrelevant, distracting information from displacing the stuff that we want to be thinking about. So attention systems and working memory systems work in tandem. Using our learning journey diagram, so the working memory system is sort of what we're aware of, what we're conscious of, what we're experiencing in the moment. Anything in the working memory system has the potential to be stored in the long-term memory system. But we're going to see in a moment here, the working memory system has a limited capacity. So that's why they use the word bottleneck here. So when we're doing mental math or reading or logical reasoning or argumentation, we're making heavy use of working memory resources, and we can quickly exceed the capacity of working memory because of this limited capacity. So we're going to just think about thinking as the stuff that's going on in our working memory. Now, of course, many other brain areas are feeding information into the working memory system. So, when we're thinking, we're activating many parts of our brain, but what we're consciously aware of, what we're consciously thinking about, that would be the contents of the working memory system. Now, you may have noticed in your own life that thinking is hard. And here I want to show you 3 factors that make thinking difficult. Thinking is slow. It takes time. Working memory can only host a limited amount of information at one time, so we need extra time to process new information. Thinking is effortful. It takes concentration. Without focused attention, we can lose the information we need to think about, or other irrelevant information can enter working memory. And thinking is uncertain. It's not always successful. We may not retrieve necessary information from long-term memory, or the problem is too complex for the limited capacity working memory system. So thinking is difficult. It is slow, effortful, uncertain, in part because of the structure of our brains here. We've got this limited capacity system, so we may not be successfully retrieving information to help us do our thinking, or we may not be able to block the distracting information that can interfere with our thinking. So thinking is hard, it is slow, effortful, and uncertain. So given that thinking is so hard, are there other ways that we can achieve our goals without having to do this really difficult thing that we call thinking? Surprisingly, there is an answer. So how can we compensate for the difficulty of thinking? When we can, we use information stored in memory to avoid thinking. Memory is more reliable, and the information can be accessed quickly and with little effort. Of course, if we're going to be doing good thinking, the information stored in memory must be quality information, facts, not fantasies or that type of thing. But we're assuming that for the purposes of this lesson here. So consider then that fast and easy retrieval of information saves working memory resources. You see, if we have lots of well-stored knowledge in our long-term memory system and we can retrieve it quickly and easily, that reduces the amount of effort that we have to spend searching for that information. And so it frees up working memory resources to actually manipulate the information that we've retrieved and to add it to other information to complete our thinking. So surprisingly then, having knowledge helps the brain avoid having to think. Now, if we think about what it is we want students to get from an education, of course, one of the big categories, one of the valuable things we want students to get is knowledge. And in this course, we'll be using evidence-based best practices to install knowledge into the long-term memory system. Of course, we will learn then that some study strategies are better than others at converting working memory to long-term memory, and then on the retrieval side, extracting the information from long-term memory back into working memory. So we'll be learning about study strategies that are superior to others. Now let's get to 3 benefits to having knowledge, how it can impact our thinking. Number 1, having knowledge well stored in memory frees up working memory resources so we can think better. And we saw that a moment ago. With knowledge well stored and quickly accessible, then we don't have to utilize working memory resources to do the searching for the information that we need. It comes readily to mind. Number 2, having more knowledge of a topic makes one a better thinker about that topic. And again, psychologists make this argument that if you want to be a better thinker in any particular area, it is very, very important and helpful to have more knowledge in that area. And number 3, the more knowledge we store, the easier it is to learn more. Yet another benefit from learning more information is that it makes new information easier to integrate into our knowledge structure and to remember it. So the more we know, the easier it is to learn more. So here we see the 3 reasons to learn lots of stuff. We want to make strong memories for the information we're attempting to learn, and it has 3 benefits. Helps avoid the slow and difficult process of thinking, improves the power and quality of our thinking in that particular area of knowledge, and it makes learning new things easier. Now, there will be times when we are forced to think, or we might be motivated to think. And it is helpful to have a technique that can improve our performance. So we can think of this as another thing that we want students to get from an education, the capacity for critical thinking. And we'll be introducing a scientific thinking format in this course. And whenever we're doing this kind of thinking, we are utilizing the working memory resources. The structure of the scientific thinking looks like this. It's the if and then structure. If a given hypothesis is true, and this would be sort of a first attempt to explain something in the world or in nature or about ourselves or whatever. If a hypothesis is true and we make some kind of observation or perform some kind of experiment, then we can make a prediction about what result we should get if the hypothesis is true. We compare that prediction to the actual result of the observation and the prediction, and then if the 2 match, we would say the hypothesis is supported, and if the result does not match the prediction, we would say the hypothesis is weakened. So this is a thinking tool. And fascinatingly, it was a cultural discovery. It's a tool for thinking and producing knowledge, and it's a fairly recent cultural discovery. And this is why the pace of knowledge acquisition has increased dramatically in modern times. So when we're going to be using the thinking format, we'll be using our working memory system. And this format, the if and then structure, is going to help us keep track of our thinking and guarantee high quality results. This is the kind of the key to the success of the scientific enterprise. We are testing ideas against our observations and experiments, and this thinking format helps us keep track of the results of that process. Now, people with lots of knowledge and powerful thinking tools often report that thinking is fun. So let that sink in. Hopefully you'll discover that it's fun to utilize this capacity that our brains make available to us. We can store lots of information, and we have discovered a powerful thinking tool. It is reported by many people that makes thinking fun. We've also encountered some of the psychological research on curiosity, and you'll recall that when we gain knowledge, that can trigger our curiosity because we become aware of gaps in our knowledge. In science and in so many other fields of human investigation and human learning, there is just so much more to learn. So we have more and more gaps to be filled. The more we learn about something, the more gaps we realize we have, the more questions we need to answer. So we can maintain high levels of curiosity, even though we are amassing more and more knowledge about that topic. So we can think then a good education is going to result in several things. We hope that a good education will trigger curiosity so we can enjoy thinking for the rest of our lives. A good education should give us some tools for thinking, so the quality of our thinking will be the best that it can be. And a good education should show us that there really is satisfaction in understanding what's going on in the world. And we hope that this will make your life more fulfilling.